Okay, this will be our final example. This is what to do when you have two constraints, and in this case, three inputs. Three inputs, not two. So, we'll call this first input g of x, y, z equals x squared plus y squared minus z squared. That's that. And we'll call this one h of x, y, z equals the x plus y minus z plus 1. Okay, now we're going to get equations from the following things. What we know, the Lagrange multipliers works like this now. It works in the fact that the gradient of f is going to be equal to lambda 1 times the gradient of g plus lambda 2 times the gradient of h. And then we're going to get that g equals 0 and h equals 0. Okay, so this gives us another unknown, because now we have two lambdas floating around, and also one more equation, and that we get the h equals 0 as well. So it just means even more algebra. So let's be brave and just go for it. So I need to know the gradient of f. It's going to be 2xi plus 2yj plus 2zk. And then the gradient of g is going to be 2xi plus 2yj minus 2zk. And the gradient of h is going to equal I plus j minus k. Well, this is going to give us three equations. So, well, several equations. So first, the equation with respect to the i's. So with respect to the i's, will give us 2x from f equals lambda 1 times 2x from the g plus lambda 2 times 1. And then similarly, we will do the j's. And in this case, the j's give us 2y from f equals lambda 1 times 2y from g plus lambda 2 times 1 from h. And then finally, with our k's, we're going to get something similar but some negatives. So 2z equals negative lambda 1 times 2z minus lambda 2 times 1. Or basically lambda 2 times negative 1. Okay. And then that g and h are both 0. So then you get also, we'll write down that x squared plus y squared equals z squared, and the h, x plus y minus z plus 1 equals 0. X plus y minus z plus 1 equals 0. So we have with ourselves 5 equations and 5 unknowns. So what shall we do first? Well, I think the first thing to do would be, just like last time, we want to leave lambdas behind. We just have 2 of them to leave behind. So the easiest one to get rid of looks like lambda 2. So I'm going to solve for lambda 2 in all of 3 of the first equations. And I'm going to get that 2x minus lambda 1 times 2x equals lambda 2, and 2y minus lambda 1 times 2y equals lambda 2, and in this case, negative 2z plus lambda 1 times 2z equals lambda 2, which means all of these guys are equal to each other. Well, you can write that as really three equations, even though it's the information of two equations. Because you can write like this is equal to that. Yeah, I'm gonna use colors. This means that these two are equal, and these two are equal, and these two are equal. But then any two of those gives you the third one. So it's really only information of two equations, even though you can do three equations to your heart's content. So what's going to seem to be best here? There seems to be kind of a symmetry between x and y, and z is kind of like the outcast. So I might want to do x with regard to z and y with regard to z, perhaps. Let's see where that takes us. Well, that means that let's just take those three and factor out the x's. So 2x times 1 minus lambda 1 equals 2y times 1 minus lambda 1 equals basically like a negative 2z times 1 minus lambda 1. Well, as long as lambda 1 is not equal to 1, I can just divide all three equations by that. That's not smart though. No, don't divide by things you don't know. So instead, solve for it. Solve for lambda 1. So in this case, these are all equal. I just factored them the way that seemed best. But I want to solve for lambda 1, not solve for x, y, or z at this point. So I want to... I can divide all these by 2 at least. So dividing by 2, you have that. Okay. Now, I'd like to solve for lambda 1 in each equation. So if these are really kind of two equations. So let's do this one and let's do that one. So solving for lambda 1 in here gives me, let's see. I got to expand it out again. So x minus lambda 1x equals y minus lambda 1y. We'll then move lambdas to one side, x's to the other side. So x minus y equals lambda 1 times negative x. No, times x minus y? Okay. Something seems wrong. Yes. Okay, new thought. Instead of that, sometimes you might find yourself going in algebra circles. And if you're going in algebra circles, it's best to stop and take a breath, maybe walk around, do some push-ups, some jumping jacks, and then come back to it. And then what I'm going to do is instead solve for lambda 2 there and then solve here, solve for, and then plug in. Okay, so solving for lambda 2 there, lambda 2 equals 2z, then moving the other one over, plus lambda 1 times 2z. So then that means that these two equations become 2x equals 2 times lambda 1 times x plus lambda 2, which is really 2z plus 2 times lambda 1 z, and then 2y equals 2 lambda 1 y plus, and plugging for lambda 2 is 2z plus 2 times lambda 1 times z. Well, if I plug in, or if I solve for lambda 1, and then of course, like these guys just stay the same. All right, then if I solve for lambda 1 in here, let's solve for lambda 1 here, then, so now I'm moving in the right direction because I'm leaving behind lambda 2 now. There's no more lambda 2. I'd like to leave behind lambda 1 as well. So if I solve for it, take that equation and move all non-lambda things to the other side. So, and let's also divide by 2. So like y, and subtract. Let's do it in stages. No, just see how there's all these 2's there. So dividing by 2 gets rid of all 2's. Okay, now y, then subtract the z over, so minus z equals lambda 1 y plus lambda 1 z. And so then that means that y minus z over y plus z equals lambda 1. Well, that means that I can now plug that in to plug in lambda 1, plug in lambda 1 there, and then I have no more lambda 1. So then plugging that in here, I'm just going to kind of put it down here. Let's start over. So 2x plus 2 times y minus z over y plus z times 2x equals 2 times lambda 1 times x plus 2z plus 2 times y minus z over y plus z times z. Okay, that's a z. Those are z's. That's 2's. But again, all the 2's are there. So dividing by 2 gives me a simpler equation. Now let's see. So I have this equation, which I should try to simplify if possible. So how about subtracting the z over x minus z equals y minus z over y plus z times x plus y minus z over y plus z times z. So if I multiply by y plus z, then I have x minus z times y plus z equals y minus z times x plus y minus z times z. which gives me x minus z times y plus z equals, they have the same factor there. So then I can y minus z times x plus z. Okay. So now I have this equation, and I do need to let's bring those other two in now. So I have also x squared plus y squared equals z squared, and I have x plus y minus z plus 1 equals 0. X plus y minus z plus 1 equals 0. Well, now I'm down to 3 equations and 3 unknowns. I'm making progress. I no longer have the lambdas clogging things up. So where do I go from here? I would probably go with my easiest equation and then use it to go down a variable. So for instance, if I were to say solve for z here, z equals x plus y plus 1, right? Then I can plug that in there, and I'll get 2 equations with 2 unknowns. That'll be messy, but we can be brave. And so I get x minus x plus y plus 1 times y plus x plus y plus 1 equals y minus x plus y plus 1 times x plus y plus 1. Well, simplifying that, I get negative y minus 1 times x plus 2y plus 1 equals, those cancel, negative x minus 1 times 2x plus y plus 1. And then if I were to just multiply both sides by negative 1, I could get y plus 1 and x plus 1 there. Okay, then the other scenario, I have x squared, the other equation. So that was equation 1. Equation 2 is x squared plus y squared equals z squared. But z squared is x plus y plus 1 squared. All right, well, x squared plus y squared equals then x squared plus 2xy plus y squared plus 2. So then each of these is going to be x times, this squared is like this times itself. So x times, let's do a more formulaic way. X times everything. X times each term. X times x is x squared. X times y is xy, and there's 2 ways to get that. X times 1 is x, and there's 2 ways to get that. And then y times everything. I've already done y times x there. Y times itself is y squared. Y times 1, there's 2 ways to get that. And then 1, I've already done 1 times x, I've already done 1 times y plus 1 squared. Okay, and so then, canceling out those guys, I'm left with 0 equals 2x plus 2xy plus 2y plus 2y plus 1. Okay. And so these are my 2 equations. And we're getting there. We have 2 equations and 2 unknowns. Let's write them just together. So let's write this one right beneath it. So I've got the y plus 1 times x plus 2y plus 1 equals x plus 1 times 2x plus y plus 1. Okay, so two equations and two unknowns. Maybe it would be best for me to FOIL this out and simplify the second equation. I might better know how to use the two equations together if I were to do that. Really, um, let's again stop and think. Yes, our we have two equations and two unknowns, and it's best. This is factored, but not in a way that's useful. So I need to expand it and then refactor. So let's combine all the terms. So we've got y times everything is yx plus 2y squared plus y. Then 1 times everything is plus x plus 2y plus 1 equals, and then x times everything is 2x squared plus xy plus x. Then 1 times everything is 1 times 2x is 2 plus y plus 1. Okay, so then these three terms were y times everything. These three terms were just the thing repeated. These three terms were x times everything. These three terms are just the terms repeated. And now let's look at what we have here. Well, what things cancel? There's a xy and a yx on both sides, which can cancel out. There is there's just an x squared and a y squared there. And so then, what else can we do? So maybe let's just move everything. Let's move everything over. Also notice we can cancel out the ones. And then move everything over to the left side, perhaps. So then, if I move everything over to the left side, I have, well, there's other things I see I can cancel. So there's a y here and a y there, and an x here and x there, which means I have just, and then I can divide by 2, so my only terms that are left have 2's in them, so divide by 2. What am I left with? I'm left with y squared plus y equals x squared plus x. So that means that let's see. It's definitely simpler. Simpler how? So y times y plus 1 minus x times x plus 1 equals 0, I guess. That's one way to say it. Or, at this point, man, it'd be nice to be able to factor one of these guys. That would be best, in my opinion. Okay, so, what else could we do? We could, at this point, we could start doing quadratic formula, but that will make things messy. So instead, we could try solving for x in the first equation. So this is equation 2 right here. Let's solve for x in this is kind of, I simplified the second equation. Let's solve for x in the first equation. Solving for x in the first equation, we'll move so that was kind of like all its own thing. Let's not circle. It's kind of like, okay, it's equation 2. Equation 1, solving for x. We move x things over. So we get 2. Well, let's solve for y. It's symmetric, so why not? So we'll move non-y things across. So then I've got negative 2x minus 1 equals 2xy plus 2y. So then y equals negative 2x minus 1 all over 2x plus 2. So that means that I've solved for y. I can plug it into this final equation, and that'll give me a single equation with a single variable. And so then here, plugging this in, I then have, I'm going to write my x squareds over here, plus, or no, it's all going to be fine. Okay, so y squared will be negative 2x minus 1 over 2x plus 2 squared plus negative 2x minus 1 over 2x plus 2 equals x squared plus x. Well, I guess x squared 2x plus 1. I can multiply by, let's see, x plus 1. So if I multiply everything by 2x plus 2 squared, then I'll be left with negative 2x minus 1 squared plus negative 2x minus 1 times 2x plus 2 equals x times x plus 1. That's me factoring there. And then it's because like 2x plus 2 squared is really like 4 times x plus 1 squared. And this is really like x times x plus 1. So I'm going to get 4x times x plus 1 cubed. Okay, so then that means that I have to, I need to simplify everything. So then I've got 4x squared plus 4x plus 1, then minus 4x squared. Then outside terms is minus 4x. Inside terms is minus 2x. Last terms is minus 2 equals 4x times cube of soap. No, it's 1331. X cubed plus 3x squared plus 3x plus 1. So several things cancel. And so then I've got basically negative 2x minus 1 equals 4x to the fourth plus 12x cubed, so multiplying the 4x times everything, plus 12x squared plus 4x. So adding 2x plus 1 to both sides, and I get 0 equals 4x to the fourth plus 12x cubed plus 12x squared, adding 2x plus 6x plus 1. Okay, so then I'm going to take that, and I have, I can plug that into Desmos, find the roots, and that tells me all the x's. So my sharing, gonna change the sharing to be my whole screen so you can watch me do Desmos. And then just got to remember it. So I think I'm going to need to kind of do a two-screen scenario here. There, and need to use the internet. And here we go into Desmos. And over here, I need to be able to see. Okay, start graphing. And I have 4x to the fourth plus 12x cubed plus 12x squared plus 6x plus 1. And so there are only two roots of this polynomial. And so then I know that in that case, x is approximately negative 1.707 or approximately negative 0.293. All right. Then you just go backwards and figure out, well, what is y in terms of x? I solved for y. It's negative 2x minus 1 over 2x plus 2. So then, so I'm going to put those in. Let's say x, maybe create a table. So, no, that's the wrong thing. The addition plus table. And so my x values are negative 1.707 and negative 0.293. And then y1 instead, this is going to be equal to my formula, which is negative 2x1 minus 1 divided by 2x1 plus 2. So then, and then over here, when I solved for z, isn't that funny how that's basically the same number? Huh. All right, that makes sense since it's symmetric. And then over here, what was, when I solved for z, what was z equal to? It was x plus y plus 1. So then over here, I get x1 plus y1 plus 1. I don't think it's letting me do that, but I know that y1 is x1. So then I'll just substitute that in. And so then I get z is those numbers. And that gives me my answer. So then that tells me that I've got these look suspiciously like square root of 2 numbers. So there we go. So let's see. Negative 1.707. That looks suspicious. So what is negative 1.7072136 squared? Yeah, I have no idea. All right. It's something oh, stop. Okay. So there we go. That is how we solved that problem. It was messy, but we were able to do it. Okay? And that's the lesson. All right, bye.